two examples of ideal gas law problems. In the first problem, let's check it out. We have a 23.8 liter balloon. It is filled with 88 grams of carbon dioxide at 15 degrees Celsius. Okay. The question is saying, what is the pressure in kilopascals? All right. One of the things I think we need to look at here is that we have two gas law equations. We have, the famous PV equals N, R, and T. That's the ideal gas law equation. And we also have P1 V1 over T1 equals P2 V2 divided by T2. One of the things students often will say is, which equation do I use? And I just want you to check this out here, okay? I have a volume, and we'll just label this here as volume equals 23.8 liters. We got that going on. We also have 88 grams of CO2. Now, I've given you that. Where does that fit into these equations, actually? It's actually could possibly fit into, right there, moles. Okay? N is moles, and it could fit into that. We'll come back to that in a minute. We have temperature at 15 degrees Celsius, and anytime I have Celsius, right away I like to do plus 273 to get it to Kelvin, and that's going to give me 288 in the Kelvin. So it needs to be in Kelvin. Make sure your temperature is in Kelvin for all these gas law problems, regardless of which formula you use. And lastly, the pressure is going to be expressed in kilopascals. So the question is really, what is the pressure? I want you to check this out, guys, is that we have a formula PV equals nRT, and this formula with pressure here and pressure there. You'll notice here only one pressure has been given. You'll notice only one temperature has been given and one volume has been given. So really, you can't use this formula because it requires at least two of these variables. So what I'm saying is that this formula really cannot be used. Not to mention, it cannot handle the fact that we have 88 grams of CO2. Whenever you're given grams, something you really just want to do quickly is go convert it to moles. Okay, grams to moles is really easy. So if we're going to solve for N here, N is the number of moles. We're going to do the weight on the periodic table of CO2. Now bear in mind, carbon weighs 12, oxygen weighs 16, and oxygen weighs, excuse me there guys, 16. So it's really 1 mole divided by 12 plus 16 plus 16, or really 12 plus 32 is going to be 44 grams. Let's just stop very quickly and just do 88 times 1 divided by 44 grams to find out how many moles of CO2 I have. And what you're going to find out is that we have 2 moles of CO2. Now, the fact we have 2 moles of CO2, we have a temperature of 288 Kelvin, we have a volume of 23.8 liters, and the question is what is my pressure in kilopascals? So we're looking for a pressure in kilopascals. Let's plug this into the PV equals nRT formula. The pressure is what we're solving for, so we'll just leave it like that. The volume we see was 23.8 liters. One thing you should know is that the volume in this equation does need to be expressed in liters. So if it's given to you in milliliters, please convert it into liters. The N is what we just solved for. The number of moles was 2 moles. The R is the ideal gas constant, and anytime I use kPa, I'm going to choose the R value with the ideal gas constant of 8.31. That would be given to you if you're in my class and you're taking the test. I'll give you that variable. And lastly, the temperature expressed in Kelvin was 288. My pen is a little bit jagged today. I'm sorry about that, guys. And so we're going to solve for P. And what we need to do then is do P equals, and we're just going to take our 23.8 and bring it down over here. So it's going to be 2 times 8.31 times 288 divided by 23.8. Let's just pause and solve that. And the pressure comes out to be 201 kPa. Okay, so once again, guys, choose your formula correctly. Once you choose your formula correctly, just check out your variables. Just a little reminder, temperature must always be Kelvin. If you're going from grams to moles, just divide by the periodic table mass. The periodic table mass in this case was 44. That's another biggie there. And your volume should always be in liters, all right? Lastly, whatever your units of pressure is, make sure you choose the R value for that appropriate unit of measure. All right, guys, let's go on to our next problem here. Same thing here. Let's check out what kind of formula we're going to use. We have the 2 formulas we're going to use. In this case, we'll look at the variables. A closed glass jar with an unknown volume is filled to 2.5 moles. All right, well, right away, I've been giving you moles right here. So you know you have the formula that you need to use moles, which is going to be PV equals nRT. The pressure of the gas inside, which happens to be neon, is 200 millimeters of mercury. The temperature is negative 100 Celsius, and the question is, what is the new volume? You know, one of the clear, easy things here is that I've given you one pressure, one temperature, and one volume. And in that case, we're going to be using the PV equals the nRT formula. All right, let's plug the numbers in here. The pressure ended up being 200 millimeters of mercury pressure. We're given here the volume is something we're solving, and it's going to be expressed in liters, though. At least we know that. The N is the number of moles. The R in this case is going to be, because it's millimeters of mercury, anytime it's millimeters of mercury, the R value is going to be 62.4. And lastly, the T. Okay, T is a little interesting here. I've given you negative 100, so negative 100 degrees Celsius, you convert that to Kelvin, plus 273 is going to equal 173 Kelvin. Still a lot of energy, relatively speaking, in negative 100 degrees Celsius, so we're definitely going to reference that in Kelvin, showing how much energy is there. Definitely a decent amount of energy. So let's go ahead, guys, and plug and chug. That means let's plug our numbers in. We have PV equals nRT. When I go ahead and start plugging these guys in, we'll end up having the 200 millimeters of mercury right here. The volume is what we're solving for. Excuse me for that little line there. It should be a curve. Volume is what we're solving for. The number of moles was expressed as 2.5. The R value I chose was 62.4. And lastly, the temperature is in 173, kelvins. All right. So what we're going to do now is isolate the volume. And in order to isolate the volume, we're simply going to take the 200 over here, and we're going to divide this side by the 200. And I guess you could say you're actually multiplying this side too by 1 over 200 to cancel it out. So let's go ahead, guys, and calculate the volume. It's going to be 2.5 times 62.4 times 173 divided by 200. And what we end up with is 135. It's 135 liters of gas. Once again, really sorry today, guys. The pen doesn't seem to be what it should be today, and it's a little jagged. Anyway, guys, a little recap here. Once again, pull out the givens from the problem. I see right away that I have moles, and moles can only be used in the equation as PV equals nRT. Also, likewise, I see one variable of pressure, one variable of temperature, and one variable of volume. Therefore, it has to be this formula. You cannot use the P1V1 over T1 equals P2V2 over T2. Okay. Next thing you want to do after you choose your formula is just look at the problem. Label those givens. If it's in moles, that's awesome. Last time we didn't have that way. Choose your correct R value, and lastly, add 273 to any temperature that's Celsius, and you'll have yourself a Kelvin, the number of kelvins. All right, dudes, that's all it is for today. I just want to wrap up with 2 examples of the ideal gas law. If you want some practice on the combined gas law, I do have a video on that as well. Just look back a couple of videos, okay? All right, dudes, thanks a lot for tuning in. Hope it was helpful. Be good.